So today we will learn about how a wave propagates. If you recall, what is a vibration? Imagine a particle like this. If a force displaces it down, then it will go, but then restoring forces will bring it back because it is elastic. And here it will not stop, its inertia will take it to the other side. But as soon as it crosses, the restoring forces will again bring it back. And then the particle will vibrate down, up, down, like that. So it will repeat that. Now say these are the particles of a medium. So this is A, B, C, D, E, maybe F. Now we disturb, say, particle A. Say this particle is disturbed so that it begins to vibrate down, up, down, like that. But the vibration does not remain confined to only this particle. It will start to travel to B, to C, to D, to E, like that. Now think about this. As the particle A is vibrating, say it is going down, then it is coming up, then again it's going up and coming down. Say it completes one vibration. And in the time that it takes to complete one vibration, say the disturbance has reached F, which means when A is starting on its next vibration, F will also start to vibrate. So A and F will vibrate in step with each other. That is called a phase. So we say A and F are in the same phase of vibration. Now we define a wavelength. So what is a wavelength? There are two definitions. One is in the time that it took for particle A to complete one vibration, that is one time period, the distance which the wave traveled is called a wavelength. So that is one definition of wavelength. What is a wavelength? It is the distance traveled by a wave in the time that it took for a particle to complete one vibration. Or in simple language, the distance traveled by the wave in one time period is called a wavelength. And the second definition is the distance between two successive particles, in this case it is A and F, in the same phase of vibration. So we can write distance traveled by a wave in a time period is a wavelength. So the symbol for wavelength is this, the Greek alphabet lambda. And number two, distance between two particles in the same phase of vibration. So we are now going to use this to derive a very important relation. Of course, this will be there in the notes, but we can just learn more from this short video.